Ladies and gentlemen, please welcome to the stage founder and conference chair of BlackHat, Jeff Moss.
Your government is in control again. Here's American gladiators. Watch this. Shut up. Go back to bed, America.
Okay, today I'm not wearing the Madonna headset. I'm just going to use this stationary, static, fixed position microphone. Hey, good morning, everyone. I'm actually surprised to see as many of you here as are here. Last night was pretty epic, and I'm pretty happy about that. That's probably the best parties I've ever been to. It's probably also the most expensive parties I've ever been to, but it was also quite amazing. So, day one's over. We're into day two, a new day and a new keynote. And someone I'm really proud to introduce today is a long-standing friend, somebody I admired long before I met him, Mudge from The Loft. And he's been involved in internet technology before I guess there really was an internet. He used to play around a lot on X25, you know, TimeNet and Telenet. I'm sure he was probably involved on TDD2, if you remember TDD2. X-Ray probably, the administrative networks on X25. And he's been involved in some pretty notable projects and some pretty notable time periods in the internet. He's probably one of the guys involved with the beginning of the end of NTLM with LoftCrack. You can thank some of those guys for putting a stake in the heart of that beast. In the early days, he wrote a paper, a draft paper on a new class of bugs, buffer overflows, talking about buffer overflows, and it went on to be the foundation for work for LF1's paper, which became so famous, Smashing the Stack for Fun and Profit. And so every time you have a conversation with him, you're going down some arcane history path, and then he'll bring up an anecdote or a story, and you're like, oh, that's right. You and Kingpin did reverse engineer the RSA algorithm 10 years ago and point out it would have been a bad idea to use a serial number hash to be a secret. That's interesting. 10 years later, that comes home to roost. And so it's really fascinating how at any point in time when it's been involved in information security, Mudge gave a talk in 1999, keynote at BlackHat, talking about problems with SQL queries, problems with IDS evasion issues, problems with the management alignment, kind of going through a whole host of all the problems we as security practitioners were going to face. And here we are, more than 10 years later, and I bet we could play the audio from your keynote, and we're going to be facing a lot of the exact same problems today. We'll just change the names of the technologies to protect the innocent. But other than that, it's pretty much we are living in the same world. Okay, I'm not going to mention Icy Wiener. So Mudge is essentially going to be giving two talks today. He started at BBN, I think, in the early days, launched through the Loft, helped launch and to create AtStake, one of the earliest pure-play security service companies in the internet.com boom, focusing purely on security. And now he's at DARPA as a program manager with lots of money to spend on very clever things, looking far forward into the future, not like 1 or 2 years, but he's looking for those long leaps, things that will fundamentally change the nature of maybe how we approach certain problems. And so he's going to be talking about two things he's been working on. One is the cyber analytic framework for the first half of the talk, and then for the second part of the talk, the cyber fast track. And I mentioned to him, I said, oh, that's interesting. I don't think I've read much about cyber fast track. It sounds a little catchy. So he's like, oh yes, it goes live in 10, 9, 8. So it goes live today. So it's a program he can now talk about, something he's been working on for the last 9 months. And so with that said, I want to introduce a man that needs no introduction, Peter Zatko. Thank you.
Good morning. This is a little awkward to be up this early in the morning. These are not hacker hours. So let me start off here. My wife has a sister named Janet, and sometimes her friends come up to her and say, what's your brother-in-law like? What's it like being part of like Mudge's family. And her answer is, it's surreal. And I really didn't understand that until probably right about now. Because back in 1999, I gave a keynote at DEF CON as Mudge from the hacker group The Loft. And now I'm giving a keynote, it's 2011, and I'm Mudge, probably one of the highest ranking DoD hackers. Now the question is, would old Mudge actually look at this at current Mudge and say, did you sell out, or are you still doing what you believe in? Are you still trying to actually make that difference, put a dent in the universe? So hopefully with this talk, we'll see that, yes, that's the case. Throughout this time, it was very kind of Jeff to mention some of the other things I've been involved with. But part of the surreal area is I've testified to the Senate and the House multiple times. There are fictional characters in books based off of me. I'm even in Trivial Pursuit, which is, so I get it, Janet, it's surreal. One of the things, though, from all of these different vantage points is I've really had a unique opportunity to be able to observe and even significantly sometimes influence the cybersecurity field. So with that, I'd like to actually get down to it. Now, one of the main reasons I should actually preface this that I joined DARPA was because I was really frustrated with how the government was handling cyber. Cyber is very fast, very agile. It needs a flexible, resilient, adaptive sort of player. And when I mention those sorts of characteristics, the US government is not what comes to mind. So one of the ways I saw to fix this was, okay, I'm trying to fix it from the outside. I've been trying to do that for years. Let me jump inside and see how difficult it is to fix it from that side. And lo and behold, one of the ways I see of fixing it is to actually bridge the gap between the government and the hacker community. Now, this is something that will entail a fair amount of re-education of government officials and the media, because as soon as you say hacker, they just think criminal. And frankly, that's really not the case. The criminal element is minuscule. It's only a small portion. We have criminal elements in all sorts of other fields, be it politics, be it law enforcement, be it finance, and the criminal element in at least politics and finance might be larger than that in the hacker community. Yeah, we'll see if I still have a job after this talk. But the vast majority of people that consider themselves hackers, are you guys sitting out in front of me. They're also like game modders, they're open source developers, IT folks, security researchers. And I have no desire to co-opt either one of these areas, government or hacker spaces. Instead, I really want to find out where they're aligned and actually help encourage those aligned areas so that they can become resources to each other. This is not a recruiting pitch for the government, and this is not a recruiting pitch to the government to think more like hackers either. It's where are you aligned, and let's see if we can actually win some hearts and minds in both areas. So one of the first things I start out with is something that I helped put together and do a lot of work on at DARPA called the Cyber Analytic Framework. So DARPA's thrust in cyber is now driven by this framework. It's a pretty major muscle movement to change a lot of the investment strategies that we had. But when I went in there, and remember I went in there because I thought government was broken, and in some places I think it was, but it's fixable. So that was part of what's going on here. Slides, please. So we've all seen slides somewhat like this. There's some measure of badness in gray, and it's growing exponentially over time. In this case, it's DoD reported incidents of malicious cyber activity. What does that even mean? Don't know. But you can substitute just about any measure of badness, whether it's viruses, worms, cost to companies, and it just keeps growing up over the years. Now, the interesting part here is I went in and said, yeah, we get this, and there's this sense that things are just getting worse over time. But let's overlay and understand this a bit more specifically. The red line that I put on there, that's the entire federal defensive cyber spending budget in billions. Now, the problem with charts like this is that they lead you to believe that success is measured by driving those gray bars down and lower. if you keep putting more money in, if that red bar is growing up higher and the gray bars continue to grow as well, this is really not good. If you want an analogy that, again, I'll probably get in trouble with, think of the Cold War with US and Russia and the spending, and right now we're looking pretty much like Russia. So the question is, why is this the case? Because that's really disconcerting. And it turns out that in many ways, when you look at different ways of actually measuring, actually quantifying where the divergences are, that's exactly what it is. A lot of our efforts are actually divergent with the evolving threat that we're trying to deal with. So this is a slide that's gotten a little bit, probably too much press and media in at least the DoD circles, and it's offended some folks. Let me walk you through what we did here. On the left is lines of code, and on the right are time frames. And the blue line, I went and I took a bunch of defensive pieces of software, and I manually went through and counted the lines of code. Notable callouts, DexSeal, Haystack Labs, Stalker, those were some of the first application layer firewalls. Then you see, Milky Way was one of the first commercial kind of firewalls and VPNs. Snort, that was when Snort first came out. So Snort actually now is much further up on the blue line. We're all familiar with Snort. We all love Snort. Network Flight Recorder I put on there because it was one of the first examples of a security appliance. You just buy it, you take it on your, put it in your rack, you plug it in, and you're supposed to be good to go. And on the top right where we see unified threat management, that's your all-in-ones. That's your antivirus, your firewall, your IPS, your IDS. If we name names, that's your HBSS, your host-based security system that is used throughout the DoD. These are a lot of the products that places like Symantec, McAfee, CA Unicenter, et cetera, are offering. By 2005, we were up at, 10 million lines of code. So I did the same sort of measurement for operating systems, and you can see all the way on the left from like Minix going up to Windows and Linux, 156 million lines of code, and the same thing for applications as well. So the individual office suites you're working, those sorts of applications, those are in the millions of lines of code. So what happens when we go through and just take, I don't know, let's take Millworm. And let's go through all the exploits, viruses, botnets, worms that they have on there. Let's take all the stuff on Backtrack, on offensive computing, from my personal collection, throw them in there and count the lines of code through time. And that's what that red line is. And I was surprised by that too. They remained relatively constant at 125 lines of code. Now, lines of code was chosen not because lines of code itself is magic, but because lines of code is a really good proxy. You can substitute in time, complexity, effort, and most importantly, probably money. And it all stays the same there. So let's play a little game here where we substitute in money for lines of code, where $1 equals 1 line of code, because we're in Vegas after all, right? I'll take the blue line, because I'm an idiot. You can have the red line. What this means is I put $10 million down on the table. You put $125 down on the table. If you win, and all you have to do is find a problem anywhere in my system, you get to keep it all. If I win, which means I have to defend against every single possible attack you could possibly throw at me, I keep it all, which means I've got $10 million and $125. Not really odds in my favor, but I might be able to find that game somewhere around here in Vegas. So I'll play a few more rounds. Somebody needs to tell me when this really isn't the right thing to do. I'd like to point out, because some folks accurately said, I got some responses, they said, well, that doesn't seem right. There are some botnets that are like 125,000 lines of code. And I said, yeah, that's true. And I actually had those in the collection, because this is how averages work. How many lines of code in a SQL injection? Yeah, 1. How many SQL injections compared to botnets do we see out there? That sort of thing goes on. Another interesting part here is that originally when I did this in GNU-plot, which it's now been gone over and Microsoftified, the red line there for 125 is really just overlaid on the x-axis, and you can't see it. It's not separated. So I had to move the red line up for this chart to make it visible. That's actually at about 125,000. So this story doesn't change whether this is 125 or 125,000 lines of code for the red. And it really feels unfair if you're on the blue line and you keep building these large monolithic defensive structures. I agree. That stinks. So I wanted to look and actually explain some other areas where we are. Somebody referenced, I think, somebody is laughing because they recognize some DoD sorts of DTS, the Defense Travel System, is great. I have to click through the, this certificate is invalid, okay, every time. Yes, I'd like reimbursement from my travel. The heck with security. Now I'll hear about that one now too. Other areas where we are divergent, and oftentimes it can come up and actually surprise us. Passwords. I love passwords. I know a little bit about passwords. And in certain areas that are really security conscious, they'll have some pretty complex password complexity guidelines that you have to follow. In fact, for a lot of the folks, particularly in DoD or government contractor areas, they know that if you're using password, that 15 is a magic number. Why? Because if it's 15, Microsoft says, oh, I can't make a landman hash out of that, and gives you this error box that says, warning, you're not going to be backwards compatible, okay? It's like, yes, that's okay. Very okay. So 15 letters. Interesting. Might have just chosen to disable landman, but okay, I'll go with it. I have to type in a 15-letter password now. I have to do this also, so a little schadenfreude, I'm a victim of this myself. I did it to me. Well, no, Microsoft, you did it to me, but it's okay. But I don't know too many 15-letter words. So, well, I don't speak German. If you speak German, this might not be an issue. So what I'll do is I'll probably take 2 words and I'll concatenate them together. Remember, I've got a requirement of 15 in this environment. And that's not good enough. It says, got to have more, got to have numbers in it. It doesn't take me too many times after realizing every month or 2 months that I have to change my password that the numbers move to the end and I just increment them up. But it has to have a special character, maybe an @ sign, an asterisk, a hash. I'll put that in between the 2 words, and it has to have mixed case, uppercase and lowercase, because hey, we're in NTLM land now. So I'll capitalize the first letter of the first word or the second word, or maybe both. That's great, but if you do this in certain really security-conscious environments, people's face turn white because you've basically just played the amazing Karanak and blind guessed their password. A real fun way of driving this home was some colleagues of mine, some old friends, CoreLogic, they ran the Crack Me If You Can contest last year at DEF CON. A lot of fun. They're running it again this year. And part of the rules to play were that you had to describe your approaches and how you were, and kind of document it as you were going along. So that was really neat because we learned some neat stuff from this. This is a profile of the winning team, Team Hashcat. I always give them a good shout out because they really enabled me to drive this point home. And the interesting thing is not that they had cracked 38,000 of the 53,000 passwords. That's actually not the interesting part. The interesting part is how they did it. If you look at the blue line as it's going across over time, they had 48 hours, and it shows the increase in the number of passwords they've managed to collect. At the beginning, it's just gradual because they're blind guessing, they're brute forcing. And then they basically stop and they look at what they've gotten, and they look for patterns. They go, huh. They're taking 2 words and putting them back to back and putting numbers at the end and maybe a special character in between. And they plug that template back into their password guessing. And that's where you see it shoot up. And then they exhaust that because they've basically gone through those passwords that they can find, and they start brute forcing some more, and that's where you see that little plateau. And then they stop and they say, what did we learn from this one? Aha, mixed case. Try capitals in both of the letters, and a couple of other things, and they plug that back in, and that's where it shoots up. So in the matter of 48 hours, they've actually learned a lot of the characteristics that, for good, strong security reasons, we've been trying to enforce on our users. It's an unintended consequence. And in fact, this is something really important because it's not just how the adversary is going to view your solution, it's how your users are going to embrace it and what things they're going to do that becomes predictable. We're really not thinking very far into the future. We're really only looking at a single step forward in the whole game theoretics of this. So I was still on the analytic framework. We wanted to look for other areas where there was divergence and why we couldn't get ahead of the problem. This is a vulnerability watch list. JTF-GNO, which is the Joint Task Force Global Network Operations, is now part of Cyber Command. And they have a huge job ahead of them. Or not even ahead of them, they do this now. And it is just amazing. 15,000 plus networks, they've got to monitor all of the systems across them to figure out who's got vulnerable software, who's up to patch level, what stuff is not in compliance with the configuration policies. And in many cases, as you'll see here, there are fixes for security bugs that they're waiting on from vendors. Or there's a security problem and the vendor doesn't know how to fix it. Or there's a patch but it hasn't been deployed out. And they have to keep track of that. And this is one of the vulnerability watch lists from a little while ago. I sanitized it because I didn't want folks to see some of the specific names, because where you see that there is still awaiting a response or that there's no fix available, yeah, it's still probably a vulnerability. So I'm trying to protect the guilty here. It's really frustrating when you look at it and you say 6 out of the 17, so over a third of the vulnerabilities that they were tracking in their watch list were in the security software that we deployed to protect ourselves. Let me say that again. 6 of the vulnerabilities are in the security software. You wouldn't have been able to get into that site except for the fact that there's a remote privilege escalation vulnerability in a very major antivirus package that has to be deployed on everything. So how can you win on that one? And we sat there and just kind of hung our heads because I don't want everybody to be like, well, this sucks. I heard Mudge's talking, man, we're screwed. We realized why this was. If you remember that chart with the lines of code, well, most of these applications are over 1 million lines of code also. And we start thinking, well, we want defense in depth. But what we're really doing is layering security solutions on top of a unified architecture. And that's not giving us defense in depth. It's instead actually greatly increasing the surface area and the complexity that when I'm playing opposing force, or when I'm playing red team, or when I'm attacking a system, I go after that. And any of us who've been on a pen test, you get this real fun, sort of like, I'm going to stick it to you when you get to go in through the security software itself. So what are other areas where we can look at the size of this attack surface? What this chart is I went across DoD systems, a whole bunch of different types of environments, and you see the same thing in the commercial world, in the private sector, and in the kind of like, ugly brownish red that's going across, I laid them out in their size. And for size, I counted the number of functions that the program had natively on its own. Again, functions here is just a proxy for lines of code. So if I think of the Microsoft calculator application, that's probably around file number 20 on the x-axis there. And if I think of Microsoft Excel or Mathematica or MATLAB or something, that's probably up around file number 140 or 150. I should point out the y-axis is log scale here. So you'd think that a smaller application like Microsoft Calculator would be a much smaller target. And smaller targets are harder to hit than larger targets. More nimble, fewer opportunities, less complexity. Okay. But that's not how our modern operating systems actually work, is it? We have really complex runtime environments. You try building a statically linked application on one of these things and see how much grief it gives you. It's like, no, I'm not giving you the static build of libc, to link against. This has got to be shared. This has got to be hooks into DLL. So the runtime environment is bringing in extra libraries, extra support routines. And so for each of these applications, when they're run, I counted the number of functions that were mapped into the process space, and those are the green lines right next to them. So for a view that's kind of like return-oriented programming, or as Dino would say, like borrowed instruction set computing. I guess there's some sort of like patent trademark war going on there, I don't know. That's the view that you get. There's no small target and large target. Everything's a large target in our modern operating systems. So these, again, are different views and different ways of looking at things. I'm really particular. The every 1,000 lines of code, 1 to 5 bugs are introduced. That was a metric that IBM put out a while back. I found that to be pretty consistent. What this means is for those 10 million lines of code, defensive applications, that's 10,000 bugs. Not all of them are going to be exploitable, but some of them are. For a major operating system of 156 million lines of code, 156,000 bugs. Those individual applications on the vulnerability watch list, million lines of code, 1,000 bugs. Yeah, so we are really creating a very large and complex surface area, and that's very difficult to actually protect. Now, the last part in this section of the talk, this is one of my favorite ones, but it's a little complicated. So I'll give you the punchline up front. In certain situations, we've actually incentivized the adversary to want to get caught repeatedly, and we've incentivized the defenders to not actually want to solve the problem. Now, that's some pretty freaky game theory right there, especially when we keep complaining about security all the time. So let me paint you this little hypothetical game that we're going to play here. We're writing the Storm botnet, one of the first well-known peer-to-peer botnets, also called New War, PCOM. And one of the first choices we make is, well, do we want to do a traditional command and control? Maybe not. We know that a lot of folks are getting pretty smart, pretty active at how to disrupt the single command and control, and that basically orphans and disables our botnet. So let's do the whole like Kademlia distributed hash table route, and let's make a peer-to-peer botnet. Okay, so we've got that out there. That's our tree. Now we want to actually protect some of the communications back and forth between all of the different agents or all of the different zombies or bots. So let's obfuscate it. And we'll obfuscate it with basically a trivial XOR string. And we'll just bang it in, push it out, propagates throughout the peer-to-peer botnet. Take about 5 minutes, 10 minutes to do for tens of thousands of compromised hosts. Not super strong security. The XOR string was smaller than the amount of material that they were actually using it. So you could pretty much, if you just strings it against, all ones, binary ones, or 0xFFFFF, you kind of see the key starting to pop out. No problem. And it started getting some news. And it was used for a lot of spam campaigns and pump and dump stock stuff. And the antivirus folks would come out with signatures for it. So the signature process for the antivirus folks was kind of as follows. Grab a copy, grab some samples, reverse engineer the key for the XOR string, come up with my signature, test my signature, deploy the signature out to all of my subscribers. And that would take on average about a week, week and a half. At which point, what would the bot herders do? Rekey. Bang away on a keyboard. 5 minutes later, it's all rekeyed. AV folks would go through and say, reverse engineer it, come up with a signature, test the signature, push it out to our, et cetera, et cetera. Lather, rinse, repeat, lather, rinse, repeat. So, kind of interesting. Minimum amount of effort on the bot herders, and they get about a 1.5 week runtime free. Then something really hinky happened. They switched from DES over to AES. And at first you go, seems logical. They did a pretty decent implementation of it, and they ran for half a week, for a week, week and a half, no signatures coming out. 2 weeks, a little bit further, no signatures. Hey, they've won, right? Then they ditched the AES and they went back to the XOR. Why would you do this? Well, there are a few reasons. One, I, as the quote-unquote bad guy, might want to know if you, the antivirus industry, have a way of detecting this that I'm not aware of. Do you have something in your back pocket? And if you don't, I don't necessarily want you to come up with it, because it's not going to be a simple thing that destroys one of the branches. It's going to be something that's probably more baked into my actual botnet. Maybe it's the timing between the communications. Maybe it's something about the host activities as I start to look at them en masse. But at the very least, it's probably going to be a single signature that's going to at least take out the tree. A one-shot, one-kill sort of thing. So, going back to the trivial XOR, guaranteed run rate, minimal amount of recurring effort that they have to put in. Want to know the part that just takes my head on this? That works great for the antivirus folks too. What's their revenue model? It's a subscription service. The more signatures they can put out, the more value they can show that they're giving you. So by plugging out a signature every week and a half, this is pretty cool. It's an evolving, changing threat landscape out there. This is why you're paying me your recurring revenue stream for that subscription service. Now, could they have come up with a signature for that one-shot, one-kill for AES? Yeah, fair amount of work, and they would have done it. I'm not saying they're bad. I'm not saying that they want these things to stay the way they are. But the steady state, the Nash equilibrium that we've kind of reached here is the bot herder wins, the antivirus folks win, and it's just basically you and I, the consumers, that are kind of on the losing edge of this, or the losing end, if you will. They're not in cahoots. Get me straight. I'm not saying that. I don't think. Mudge, formerly of DARPA. But they're unintentionally incentivized. So when we look at the commercial marketplace, they have particular goals, and the government has particular goals. And when you look really closely, oftentimes they are cross-incentivized. So when we assume that the commercial world will solve the DoD's problems, or even parts of the other commercial world, you really need to look under the covers and figure out where the aligned incentives are and where you're cross-incentivized. That's basically what I'm trying to do as the end of this part into the next one, which is trying to identify where things are aligned and funding and injecting energy and power and capabilities into them, which is what DARPA program managers are supposed to do. So as the segue, it's kind of funny, and I've got a little payback to do to somebody. Brian Snow, who used to be a very senior person at the National Security Agency, last year in 2010 was up at the RSA cryptographers panel. So that's Rivest, Shamir, Marty Hellman, Whit Diffie, and Brian Snow. I mean, these are gods to me. These are heroes. And when they were asked what were big events that had happened that year in cybersecurity and crypto, Brian actually said, well, one of the biggest events, and I'm paraphrasing here, was that DARPA hired Mudge. And he said, the reason he finds this so interesting is, he said, and I know Mudge, and I like Mudge, and I think that's the first time he's ever said that, and it's on YouTube now. He's probably regretting that now. He said, but DARPA is this really old, stodgy R&D organization. You know, they're logy, lethargic, very, very set in their ways. And Mudge is this sort of opinionated, driven hacker. So this could either be a marriage made in hell or the sign of a new DARPA. So Brian, I'm still here. It's been a little over a year. I've got a bunch of programs running, but the one I'm about to announce now is the one that I'm most proud of. Welcome to the new DARPA. DARPA RA 1152 just went live about 12 hours ago. And to me, this is really, really important. The director at DARPA has fun telling me, because I'm like, I want to try this crazy thing. This is really going to change the world. She says, you're at DARPA. You only get 4 years to be here. So drive it like you stole it. And I'm really trying to do that. So, and yes, she says that. I think that's outrageous, outrageously cool. I announced Cyber Fast Track that I was working on this about 8 or 9 months ago. And in a nutshell, what I'm trying to do is say, we spend a lot of time and money on a single cyber program. Deputy Secretary of Defense, has quoted 81 months from the start of a project till it transitions into a program of record, which basically to us people not in the acronym world or whatever means until it sees the field. 81 months. That's over 6 years. Can you tell me what the cyber threat landscape is going to be 6 years from now? I could tell you what it is right now, and I can probably tell you that a lot of these efforts will be set to deal with what we're seeing right now 6 years from now. Yeah, not really great. So, I've decided it's time to start funding hackerspaces, maker labs, and the boutique security companies, and making it actually easy enough for them to compete for government research money with the large traditional government contractors in a way that's separate. This is not to say the large government contractors, are doing a bad thing. They're capable of doing really good work sometimes. Sometimes they don't, but sometimes neither do the other areas. But the way the government is set up, it's almost impossible for small businesses and the researchers, the hackers, the folks sitting here to actually say, hey, I'm doing some really cool research work here. How do I get funding without giving away all my intellectual property to a venture capitalist, or without giving up ownership of some of my company, or without being purchased by one of these large government contractors, and then basically, my company gutted or so. There's not really that many options. And this was driven from when I was running the loft. We all had day jobs. We said, we're doing really cool, crazy, neat stuff, and we're having a blast at doing it, but we have to do it off hours at night because we couldn't find a way for somebody to fund us to do research. Sure, they'd buy products and, things like LoftCrack and some of the other stuff started selling. We didn't actually even intend that to kind of happen. But looking at this with my DARPA hat on, I go, this is really subpar. I want the people to be out there doing the cool research work all day long. I don't want them to have day jobs and then go off and do this radical changing work at night. And when I look at the conferences, the BlackHats, the DEF CONs, the ShmooCons, the CCC stuff going on, here's a dirty little secret. On the government side, for government R&D and cyber programs, a lot of the secret sauce and magic, if you look back at it, is cited and comes from some of the novel research presented at these places. That's good because it's good, neat research and it needs to be part of larger endeavors, but that's a really inefficient way of getting good ideas into government and for getting government funding and support out into this community. So, rather than run one program and take 4 or 5 years to do it, I figured for the time and money and energy to take one program, I could run hundreds. I'm going to need some new performers to do that. People who are used to working on shoestring budgets, who are used to fast time frames, not the government time frames, that are really creative in their solutions, and that might not fit into the existing markets. It might not be a treading water sort of solution, but rather a strategic sort of long-term, hey, if I change this problem from security to crypto, the crypto domain is different than the security domain. Or, hey, what happens if I actually strip out all of the superfluous and unneeded surface area and have, the GTRS or the Superleggera version of Microsoft Word as an example. The sports car analogy is, if I want to buy a Lamborghini Gallardo, it's about like $200,000. If I want to buy the Superleggera version, the Superlight, because it's faster, because it's got less car, it's an extra $100,000. So buying less. So what happens if I have and this is just a hypothetical, Microsoft Word with its 3,000 fonts and all this capability, and I say, yeah, but I want the speed performance version. You could strip out all the Visual Basic plugins and all these fonts. I use 3 fonts anyway. And all these other components. It's smaller memory footprint, actually smaller surface area, smaller exposure. Might be a different way of doing it. Now, the good news is this sort of environment and these sorts of researchers, they already exist. We don't have to go out and try and create a new environment. They're here, partly because of things that have happened really in the past 10 years. Places like the Loft were rare. Now that's commonplace because we've got some really serious high-end computing, we've got serious networking, we've got personal prototyping, fabrication capabilities, and one of the few things they're kind of lacking is funding. So, what would happen if we actually enabled these folks to do some of the really neat research that they're already trying to engage in and maybe make a bit more of a go at it? Now, here are some of the reasons why the government hasn't been able to do this outreach before. I'll give you my Loft perspective, my at-stake perspective, from when I worked at a large government contractor, and then from when I'm in the government. From the Loft perspective, I downloaded a BAA, a broad agency announcement. I looked at research announcements, and after printing them out, they were about yay thick. And after about like 2 hours of beating my head with them, I couldn't understand the legalese, I couldn't understand the government talk. I sure as hell didn't have DCAA-approved auditing. It looked like I would need a team of like 5 to 10 people just to put together a proposal for this. Putting together that proposal would probably take me months, and then, heaven help me, if I won, I'd have to have an accounting and financial infrastructure as if I was one of the big, large defense industrial-based contractors. Okay, government as a source of funding, off the table for the loft. Let's look at stake and various venture-backed companies, because I sat as an advisor on some of the VC's boards and definitely did a lot of due diligence for them. And invariably, you look at your companies, they'd say, hey, we can go get some money from the government. No VC really wants that of most of their portfolio, because you don't get that much on the rates. It's going to take you a long time to propose. And so let's see, you're going to spend your top engineers working on writing a proposal to potentially get a small amount of money. You might spend 3 months to do it, and then you're going to wait another 4, 6, 8 months to find out whether you got it. That means you're walking away from dozens of in-the-bag opportunities that you can get out in the commercial world. So no, since we've invested in your company, you're not going that route. Go make us money in the commercial world. From the government contractor side, well, I spent a couple of years working on that. Sure. They're awesome at these proposals because they're geared up to it. They do have multiple people or teams of people. They'll spend $10,000, $20,000 and weeks of people's time to write a killer proposal. And they are awesome proposals, sometimes even citing the work of places like this as some of the ideas that they got. And they've got war chests of money because they can wait for the 8 months or a year to figure out, as the government and what I have to do on the back end, whether or not that's going to win the proposal. And then on the government side, where I am currently, it's worse than all of that. It is very bureaucratic. It's very difficult to do. Instilling change in this is insanely difficult because people are very fixed in the way and they're used to how it currently operates. And that's fine for many, many areas, but I don't think that's fine for cyber. I was really lucky. I went up to the director. I have a good relation with the director and with the other folks in the agency, and I said, I want to go out and fund hackerspaces, the community, these boutique security researchers that are really doing the cutting edge work. But I don't see how I can do it through the existing process. And they said, oh, we've got other solutions for you. We've got SIBRs, Small Business Innovative Research. We've got OTPs OTs for prototypes, other transactions for prototypes, which could possibly be a firm fixed price rather than a cost plus fee. Sorry, what? I said, okay, you told me, here's what I heard, you have a way of doing this, so let me try it. And I've got 2 small companies, one of which I had to put on ice in order to take the government position. I said, I'm going to do it to myself because I want to understand any amount of pain that the performers have to go through because, surprise, nobody in the government had actually tried to walk through it themselves. So this thing called CCR, contractor registry, and WAWF, wide area workflow, and you got to have a DUNS number for it. And I said, okay, great. So I went on Dun & Bradstreet to get my DUNS number, and the website doesn't work. Okay, well, it's probably I'm on a Mac running OmniWeb. Yes, okay, fine, I'll switch over to Firefox. Still doesn't work. Okay, I'll switch over to Safari. Still doesn't work. Okay, I'll turn on ActiveX and scripting and JavaScript and everything else, and it still doesn't work. Great, okay, butt flap down, really vulnerable. I will boot up my old Windows XP system, and I will try it with Internet Explorer, everything enabled, no security posture, whatever, still doesn't work. So I call up the phone number, and I'm talking to a guy over to get my DUNS number. One of the companies had one didn't. And I said, yeah, I've tried it online. He goes, okay, sure. Can you type it in? I have all the information. I have my TIN. Maybe you have a back-end system. And I can tell that he's just going through the website also. Dumb user, can't figure it out. Great, okay, fine. Giving him the information, and he goes, website doesn't work. And I said, yeah, actually, if you look at the source code for it, I'm not sure that was just a sloppy programmer error. I think you actually might be popped. But that's a different conversation. And he said, wow, well, this explains why nobody's requested a DUNS number in the entire United States for the past 2 weeks. So I'm like, okay, this route is out of my control. This is not a good experience for the end user. Okay, go to the other company that already has a DUNS number, plug it into the CCR, the contractor registry for the government. And it says, okay, you've got to give me the list of 6 different people in your organization. One. Okay. Nope, they have to be different people. Okay. Jim, Bob, Joe, whatever. Fill that out. Then it says, okay, what's your TIN number? Great. Okay, what's your social security number? I gave you my TIN number. That's my corporate, entity. But the problem is, it's an LLC, so it's a pass-through to me. And it says, because this is going to likely trigger an IRS audit. Okay, that's good. And, by the way, we're going to put all of this information up publicly such that anybody else who wants to farm, fish, or target market you can have access to it. Okay, if you're going through all of these things and if you're willing to give up that information, I probably don't want you working on Cyber Fast Track for me. It's this whole you've self-identified as not being the security conscious person. I had as an aside, I had a similar issue. I run a program called Cinder, which has gotten a lot of confusing press because it's really about Stuxnet and next generations of advanced persistent threat. It has nothing to do with humans or insiders. And as I released the BAA, I was going, this is funny because I'm going to get a large amount of the defense industrial base and the government contractors to propose, and they're the ones that have this advanced persistent threat. Yet they're proposing telling me that they can fix it. So it means one of two things, and this was a lot of cognitive dissonance. And I gave them all a very valid shake and said, okay, I got to put this out of my mind. But it either means that, one, they don't know they have this going on in their networks, in which case, can I really trust you know what you're going to be looking for and trying to fix? Or two, they do know it's going on in the networks, but only if you're willing to pay me will I actually go look at it and fix it. So it's really strange when we're going out and actually looking for work here. Cyber Fast Track, I definitely want the folks like Hobbit that's like, man, I had to turn on JavaScript to get to your site. I'm just not interacting with it, period. So ultimately, I went back to the executives and I said, I'm unwilling to take my 2 companies through this process that you're saying, so that's no good. We have to come up with a new process. And I can't even imagine if I personally would have tried to go through the large BAA, the broad agency announcement process, like a large contractor, like they're set up to do, because I think that would kill me. Luckily for me, some other people actually did. So if you see these people, thank them. They went through hell. They experienced a lot of pain because I made promises saying, if you can make it all the way through this, I will try and document each point that is painful in dealing with the government, and Cyber Fast Track will be designed to try and get rid of those. So a couple little shout-outs real quickly here. Dino DeZovi in the upper left corner. There's Hank Leininger, that's the CoreLogic folks who ran Crack Me If You Can last year. Folks probably recognize Fyodor, Nmap, bottom left, and Bruce Potter, Shmoo Group. These people put a lot of trust in me, and they said, this is for the greater good. We will take some of the pain. Dino had to read I don't know how many pages of government crap. And they go, yeah, Mudge, I understood this. Come on. I was like, okay, thanks. You're patient 0, but with any luck, this is going to work. So what are some of the ideas of things? Give you an example of what it is we're going to fund. Upper left-hand corner, somebody mentioned audits earlier to me. Audits are fun. We always win on audits. You give me a large system with a lot of bugs in it, I'll rip and run through it. But what if we turned it around and did something really clever? So these are just ideas. Don't propose these because I already know about these and they may or may not already be funded. What if you were going to audit legacy systems? AS400, Burroughs, CDC Cybers. Why would you do that? Well, oftentimes when we come across them in environments, they get a free pass. Because, well, I don't have anything in Nmap or Metasploit or et cetera, that looks at them. But if they're legacy systems that are still operating, they're almost by definition critical. And they were built with some different assumptions than our modern operating systems. Like the AS400, its file system is a database. The Burroughs system, that's a non-von Neumann architecture. It's got different stacks for code and data. Go figure. What does that mean? Well, certain types of buffer overflows just off the table. Finally, the VAX VMS, it's got like a null byte on the stack frames there. That's almost like a little canary. So when you find an area in a historic legacy system that's naturally resilient to some of the modern bug problems and vulnerabilities that we can't get ahead of, that's a shortcut opportunity. Because we've already fielded those. We know their performance envelopes. We can actually take some of those ideas and put them into modern systems with a lot less risk of saying, clean field, Intel, AMD, would you please run this brand new chip idea that nobody has ever seen because it fixes stuff? I'm like, no. The upper right one of my personal favorites. How many people are familiar with H.D. Moore's little Warvox? A modern day war dialer using VoIP lines to be extremely parallel. A lot more fun than, well, it was a lot of fun back with ToneLoc also, but a real modern version of something like that. So I went and took two people and I said, with VoIP lines, an asterisk PBX server, some software and some media gateways, maybe over in other countries, could you make a system that could make every cell phone in an entire country ring randomly multiple times a day? It's like we're exporting telemarketing to a particular theater or area of interest. Some people have said, yeah, and that would actually change the tactics, techniques, and procedures that certain bomb makers would have. Think about it. You're making bombs with cell phones and they're ringing all the time. Somebody aptly pointed out saying, yeah, but that's going to annoy a lot of other people as well. I said, well, it's like telemarketing. We'll tell them when the bomb making stops, the telemarketers will stop calling as well. But it's a new capability. It's novel. And yes, you can run this out of your apartment or dorm room, which resulted in things like, cadet, you are not authorized to run operations out of your dorm room. Maybe, allegedly. In a matter of weeks. I mean, this is cool stuff. We can hack this together. It's that vision. It's that thinking. The bottom one, that was from last year at DEF CON. That was partly DARPA funded. Cadet Mike Wiegand took, the attritable UAVs, build your own Predator drone at a 99.95% discount. On the right, that's like 5 Beagle boards hooked up to this darn thing doing some, clever Wi-Fi sort of activity. I think you can actually see Caesar's Palace there in the left. But it's not just about these individual small efforts. Cyber Fast Track, we're going to also look at what are sort of community activities, community efforts. You're probably all familiar with the Google Summer of Code, which I think is brilliant. I think it's a great idea. What if there was a DARPA Summer of Code auditing for open source software? We all rely on it. You're using Firefox, OpenSSL, Wine, Solaris, Linux. So is the DoD. And if we actually went and said, let's do bug hunting, let's clean this stuff up, everybody else, civilians, commercial, government, will have a better environment for it. And we're going to learn a lot of neat things as well. What are some of the bugs and some of the challenges that you just can't automate finding? What are some of the most complex ones? What if we had like a kind of ponies sort of like, man, that is the most strangest, bizarrest ass bug ever, you win, in a little ticker tape parade or whatever. So we're looking at all sorts of things here. But the goal is aligned incentives because the community needs to get the benefit directly out of this. Everybody will benefit. If it's good for the community, it's good for DARPA and it's good for the DoD. Here are the recurring themes as I'm winding up here. Fast and cheap, because I've mentioned this before. Time is a really hot commodity, and cyber extremely so. Currently, the DoD doesn't actually look at it that way. Diversity. I don't want a single large monolithic product that's 10 million lines of code that takes years to do. I want hundreds and hundreds of smaller ones, because the key to a good strategy is to have multiple options. You want to say, oh, here's something we're dealing with. I've got 30 ways I can deal with that myself, or I can respond. Depending on which one I choose will maneuver my opponent. Okay, if I maneuver them here, they're going to choose the following. I can maneuver them here. Now we're actually finally playing chess if we have this many options, because it's about hurting each other, H-E-R-D-I-N-G. And open. If you're keeping the intellectual property, so the government will get government purpose rights. I'm going to be upfront because there's nothing that's going to be hidden in this. The reason why I think that's okay is you're getting funded for it. You weren't thinking about selling or targeting to the government in the first place. If you are, you already know how to do it, and Cyber Fast Track isn't for you. We've got BAAs, we've got traditional RAs, and everything else, so that's all good. But so you keep the IP, and you can either release it, you can open source it, you can go out and commercialize it and make billions of dollars. I want you to have the opportunities and the flexibilities to do it, because we need more ideas and we need new performers. Second to last slide. Whenever I find hot pockets or hot spots of creativity, especially in the most unlikely places, I'm really interested and I'm really curious. On the left, we've got Major T.J. O'Connor, Special Forces. In the middle, we've got Colonel Greg Conti, data visualization security. There's like Google hacking books out there by him. And on the right, we've got Colonel Ron Dodge. They're at West Point, United States Military Academy, upstate New York. They've got cadets going out and presenting at places like BlackHat and ShmooCon. They've got folks like Dino, Moxie Marlin, Spike, Travis Goodspeed, coming in and actually interacting with the cadets. They've been kicking butt in the cyber defense exercise against big national agencies. That's pretty weird. That's pretty cool, because I don't expect creativity out of the old stodgy military academy structure. So whatever they're doing, I want them to do more of it. So select performers, if you propose on a Cyber Fast Track and are awarded, we might have as kind of the final demonstration that you go up to West Point and you show it to the cadets and you interact with them, because those cadets right now are the colonels and the generals of the years to come. So the more influence we can have on them from our community and from our mindsets, this is a great long-term investment. The gory details. It's up. You can go download it. It has been tremendously difficult to get it out there, but the difficulty, hopefully, was on our end so that you don't have to go through the pain. With that said, it is still a government/legal document, and certain parts of it read that way. I think I managed to get the no animal use and animal experimentation out of it. I'm like, but you have to have it in there. But it's cyber. Never mind. So because of that, I mean, it's a straightforward read, and we try and be upfront with everything, and we give you lots of templates to follow along in there. We're going to get a lot of people in here. If you propose and you don't win, don't worry about it. It's designed so that you didn't have to put a lot of effort into putting the proposals together, so you can try it again. It didn't burn you out for months of work and effort. And if it goes well, hopefully we'll pour more money into it, and there'll be more opportunities there. I'm also going to go around the country to different hacker spaces and actually sit down and just walk folks through it. To see, like, okay, here's the part where the government is trying to get rights. Here's the part where you are. Depending on what you're doing here, this is what's good for you, this is what's bad for you, and just lay it out. Because if you're educated on it, everybody wins in the long run. So with that said, I really hope that the old Mudge of 1999 is looking at the current Mudge of 2011, and other than saying, why are you wearing a pocket square and you don't have any long hair, that, yeah, you're still remaining true to the cause. Thank you.